Saying it's starting, and we are live. Hello, everybody, and happy weekend. Welcome to our November masterclass. I'm super excited today to introduce you guys to Lafayette Cruz, who's here with us. Wave and say hi, Lafayette, so people can see you.
Hello, people of the internet.
Yay, internet people. So excited for you guys today. We are going to be talking with Lafayette, who is amazingly agreed to share his expertise with us today about R. And so if you don't know what that is totally okay. This is, you're in the right place. This is a perfect masterclass for people who are interested in understanding a little bit more about what a career in data analysis actually looks like. You don't have to have any prior experience. This is something that is supplementary knowledge to the blueprints that you're taking, and we're just really excited to expose you guys to some of this information. So again, please join me in welcoming Lafayette. We're going to, I'm seeing that we're getting some people joining us. I'm going to give everyone another minute here to get started. So before we jump in with formal intros and talking a little bit more about the class, Lafayette, I'm just going to ask you a couple of really quick warm-up questions. Are you ready?
Okay, yeah, sure.
Okay, cool. We're going to do a fun game. All right. So I always like to ask people these questions at the beginning while our students are getting settled in. So I'm going to ask you, okay, you can eat one meal for one food for every single meal for the rest of your life. What is that meal?
Ooh. Either pizza or fried cheese curds.
Love. Okay, that's awesome. You know, it's funny because not a lot of people say pizza. It's surprising. I feel like when this question happens, yeah, because I mean, I think pizza is universally acknowledged as like the best food in the world. But I think people get a little bit self-conscious when I ask this question, and they're like, I have to come up with something, you know, unique or whatever. I can't just say pizza. Everyone says pizza, and I'm like, dude, pizza is it. We all know you wanted to say pizza.
This is amazing. Also,
it is
so versatile. You can have veggie pizza, you can have meat lovers pizza, you can have cheese pizza. It's great.
Any kind of pizza. You can, you know, I mean, I know there's been a lot of backlash recently on pineapples being on pizza. I'm telling you, it's like the food sort of community every year has one food that they decide is the devil. Last year it was cilantro, which I also love. And this year, yeah, they hated it. They said it's awful. It tastes like soap. Why do people like it? People that like it don't have any taste. And I'm like, you're kidding me. This poor guy, this poor cilantro. And now this year, I think it's pineapple. And people are like, they think that anyone who puts pineapple on pizza is crazy. Well, I'm crazy then. I love pineapple on my pizza. So there we go.
Right.
Fabulous. We're going to start a pizza club. So yeah,
Club.
I love it. You're the president. I'll be VP.
All right, sounds like a plan.
Fabulous. Okay, well, we've got a lot of people getting comfortable. Thanks again, you guys, for joining us. So I, again, want to introduce everyone to Lafayette Cruz, who is joining us from Chicago today. Lafayette works for the Chicago Metropolitan Agency for Planning. And I'm really excited to delve a little bit deeper into your career a little later on in our Q&A section, Lafayette, because I know you had mentioned that you studied social policy at Northwestern and that you really weren't into looking at careers that were involving numbers or had anything to do with tech, but now you're an associate analyst, right? And all you do is modeling and data analysis.
Yep.
Yeah, so it's funny how those things turn out.
It is like, if I had talked to undergraduate me, like if I could go back, I would not believe myself.
Yeah, it's funny how that works out. And I think that that's so inspiring for our students to hear, because a lot of the folks that are joining us today, I know have either sort of avoided the four-year college degree, or they went to college and they said, I'm going to study something in liberal arts, and now they're really interested in tech. Or, I went to college for advertising in my undergrad, and I've never done anything with that degree. So I just love when I talk to other people who have sort of found these really great technical careers without necessarily having had that background in it. So I'm excited to talk to you a little bit more. I know students have already submitted some questions about how that transition was for you. But before we get started there, let's go ahead and talk a little bit about what you're going to be showing us today. So what are we going to be learning with you today?
So I'm just going to basically show you a few of the codes I've written and trying to run through and just kind of talk about the thought process behind it. So I guess I should talk about what my agency does. So we are the regional planning agency for metropolitan Chicago. And one of the things that I do is provide traffic forecasts for the year 2040. And then these scripts are mostly related to a model that my boss and I are developing to simulate like freight traffic in Chicago, or not just in Chicago, but around the country. And so these are some scripts I've written to analyze our output data to make sure we're getting good results. So I'm going to be showing you just a bit of these codes, and then using that to kind of introduce you to different processes in R.
Awesome. Well, I know that we're really excited to jump right in, so I'm going to go ahead and mute myself and pass the microphone and the stage and the screen over to you, and let's just have you jump in. And if I butchered your intro and there's a little bit more you want to tell us, please also feel free to start with that. But otherwise, the show is all yours.
Okay. Thanks, Dee. So yeah, that was a pretty good intro. Yeah, so I work for CMAP. I've been there for about 3 years. And when I started, I didn't know anything tech related. I avoided numbers, highest math. I'd done high school calculus, but I was like, whatever, I don't want to do that. Numbers are emotionless. I don't want to deal with that. So I started my job, and they basically said, you need to learn how to code. So here's some scripts, figure it out, you make it happen. And so the things that we'll be looking at today are some codes I used for our regional freight model. And what that does is it takes employment data from around the country, and through this 8-day long process, does calculations to determine what commodities and how much of a commodity is being shipped around the country, and particularly in Chicago. Mode, how much of it, what the touring path is, which is really cool and all, but we're still trying to validate it. So these are some scripts that I made for different purposes. So I'm going to show my point of entry matrix. So the thing is, it's easy to figure out origin and destination. I guess I should actually just show you. Oh gosh. I can just show you that input file. Actually, I won't, because that's pretty hard. So yes, this is a script in R. And as you can see with some of the notes, so basically this took our point of entry skims for the entire nation. What it was meant to do is to look at trips that were passing through the region, which is a lot harder to do. It's hard to say in a simulated model how a figurative truck or train is going to go through our region. And so what we had to do was create little flags in around the region. And if on a skim, it hit that flag, then it would record it in a matrix. That's great and all, but it didn't necessarily tell us. It gave us a flag, but it didn't necessarily tell us, what is actually going through the matrix, or what is actually going through the network. And so I developed the skim. Now, if we can look here, this is a basic process of reading in a CSV in R. Which the thing I like about R is it's pretty straightforward. Well, once you learn it, it becomes pretty straightforward. It was definitely very intimidating to me at first because, I look at a screen and it's like, I'd rather read French than try and read a script. And so it's taken me some time to figure out, but this is basically how I started. My boss gave me a script. He said, Google, Stack Overflow, figure it out, make it happen. But yeah, so these are 6 different matrices with different flags. And I'm going to copy these, and we will come over here to the R GUI. And if any of you guys are considering downloading R, I would say there's a regular R, but I prefer to use RStudio. It's just a better interface, allows you to see a bit more. Also, there are issues when you're running our model between running an RStudio and just a regular R GUI. So yeah, cannot open file. Well, that's bad. All right, guys. Oh, sorry, that was the wrong script. Okay, so it was pretty straightforward enough. And as you can see over here on the side, with the 6 different matrices with 37,000 something observations, basically they run the gambit. And so let's do this. So these are what these matrices are. They have I node, which is origin node, the J node, which is destination, and the POE, which is a code that signifies a point of entry and exit. Some of them mean they just entered once. Some of them mean they entered and exited the region. And yeah, but going back more towards the code, I guess I can show you up here. The thing I like about R is that it's open source. And so there are lots of different packages that you can use to be able to apply different functions to your script. And so I like the plier package. It just allows me to it has a lot of functions that I can just easily manipulate the data that I have. And it also, the way this functions is, you can pretty much read any file. I prefer CSVs. That's just kind of how I started, comma separated. It's what I'm familiar with, but because R is so versatile, you can use whatever sort of input file. R has its own files. Some of the larger files in the main model, which I would love to show you, except it takes 8 days to run all the way through. And I'm still learning all the ins and outs of it. But yeah, so that takes a bunch of different file types and matrices. And but yeah, there are a lot of different coding languages that do that, but I like how R does it. But yeah, so I inputted the matrices. Now what? One of the things that I've had to get good with, and this is just a good skill to have, whether you're using R or Python, any sort of script or code that you're writing, is especially with data, especially with large data sets, is quality control. As a public agency, I send a lot of our data. This model that we're developing will produce data that we'll send out to the public. And because we are accountable to the public, I don't want to send them junk data. So you see down here, this is just simple logic to make sure that check to make sure that there are no trips that were saying that they entered and exited the region, but their origin and destination is within the region. So we can test that out, and I'll explain a little bit more what that code is. Good skims. All right, I have some good data. So, especially with large data sets, and this is true whether you're trying to be a data scientist, whether you're trying to validate stuff, or you're an associate analyst with the planning agency, you will encounter data sets that need to be cleaned up. Data sets that have just a ridiculous number of variables that you don't necessarily need. Well, actually, I can show you a bit later another script I had where ended up with like 20 something different variables, which are nice and give me information, but for the tests that I wanted to run weren't necessary. So what I did here is I subsetted three of the matrices, subsetted them by having an origin zone within the region and having a destination zone within the Chicago region. And then beneath that, oh wait, am I sharing my screen? I am. Okay. And so within that, down here, you'll see it says, if else, the number of rows within this data table is greater than 0, then print internal trips present, meaning the data is bad. Otherwise, if this couldn't find any observations that fulfilled this requirement, then the number of rows within that data set will be 0, and that means it's good. Print good skims. And as you can see here, that subset created files without any variables. So we have good skims. There were no trips that occurred within the region, but were assigned a point of entry. Now, when I first was testing this data, we had a lot of trips that were going within the region, and that made no sense. And the cool thing about it is doing this testing and this quality control not only was able to confirm the quality of data, helped me figure out what was wrong with the model. Sorry, stop sharing for a sec. Yeah, and so it was showing me that basically in one of the skims that we had, there was no simulated congestion on any of the highways in the country outside of Chicago. So basically, it made more. Basically, once you left the Chicago region, you went into warp drive to anywhere that you wanted to go, which would be nice, but it's not reality and does not produce good data. So we had to fix that, figure it out. Because I still have a hard time considering myself a coder. I definitely did like a little dance around the office when I made a code that worked and that solved a problem. Yeah, it feels good. I mean, I think a lot of you will experience that when you get some really hard code or you encounter a problem and then you get it right. And you're like, oh my gosh, I am the coding king. I am awesome. And then you'll encounter another problem and then you'll humble out, but it'll be good. But yeah, so as a result, that is the test I make, because we'll end up running multiple skims of this model. But yes, so we've imported our matrices. We've tested to make sure there were no internal trips. But now we need to combine them. So we'll copy this. All right. So now, I guess before we combine them, we need to make some changes to them. Okay, so this code here this is how you merge data, which there are lots of different ways you can do this in R. I think a little further down, I use a row bind function, but this here is merging. And so I'm not sure if you can really have an opinion on being able to merge data in R, but because I use various data sets, I end up having to do it a lot. And so the cool thing is, I think the coolest thing is this little bit of script right here. That tells you which observations to keep. So right now I have it set to all observations equal true, which means that all observations in either this data set or this data table or this data table, all of them are true. So when they merge, all those records will be kept. I speak English. what I could do is say all of x, all x equals true. What that would mean is that only these two data tables would merge, but only if there was an observation in here that wasn't in here in the original or in the first data table, then the observation in the second data table would not be kept. Now I could also do all y equals true, in which case only observations that are present in this would be kept. So that's a cool way to merge data. It ends up creating, I mean, not too large of a data set. Like if we go down to here, oops. Yeah, so this is the data table that ends up creating, which is, yeah, pretty cool. And you'll also notice down here, this TRK is NA TRK POE. That's just, this is a variable manipulation that I like. With a lot of the scripts that we are running, you'll have instances where there is no observation, and so it'll produce an NA, which is nice to look at, but when you also need to take that output data and apply it back to a model to adjust the logic to, that creates a lot of errors. So what I did here is, so basically for this data table, TRK, if the variable or an observation of the variable POE or point of entry in this data table is an NA, then that variable is changed to 0. And it's a good way, it's an easy way if you have errors or you have NAs to just be able to manipulate it so that you can just make it easier to read later on. All right, I'm going to go down here. Where did I end up? Okay. So yeah, as you can see, nope, that's still merging. Okay, so what I eventually wanted to do was merge all 6 of the data sets. So up here, we already merged the truck data table, the random congestion Oops, who is calling me? Sorry about that, guys. The random congestion data table and the AM peak congestion data table. And I could explain that to you. That goes more into transportation modeling, which isn't related to R. So just know them as truck, RAN, and AMP. So we wanted to merge them all together because I wanted to know what was the probability that a trip, based on these 3 skims of our model, what was the probability that a trip would go through the region? That's what we're trying to get to. So I created this flag, which I'll eventually use to calculate probability. And then we'll go down to change the names. Okay. So, names. Yes. You can do this in any language. I've started learning how to do it in Python. But sometimes you'll get data sets that aren't, that have observations are of the same variable class, but they have different variable names. And so a very easy way to use later on is just names of that data table, and you just write out the names that you want to change everything to. So origin destination zone, the POE, the point of entry code for matrix 40, whether it's in the region in matrix 40, yada, yada, yada. It's cool. All right, so I'm going to do some more calculations. All right, so you're like, what all went on there? This was, what did I do here? Okay, so this is another instance of subsetting data. I had mentioned before you can subset by specific observation parameters like we did up here in the test. So this says any observation that fits these parameters we'll subset and keep. And down here, the subset POE select, this allows you to select the specific variables that you want. And you can do a single variable and just have select this column, or, which is more often the case, you end up doing POE select and a bunch of different things. And this was because after merging all of them, we had this long list. So I'll do this so you can see what POE ended up looking like. We ended up with this data table with a bunch of information that was all related, but not necessarily how I wanted the data table to be. So I subset the different, I subsetted the different skim cycles. And then what we do down here is row bind them. So in most any sort of code that I've encountered, you can either bind data tables by rows, so where you just stack them on top of each other, or you can bind them by column. Let me take off sharing for a bit, or you can bind them by column. And I mean, it's pretty straightforward, but I think it ends up being good because there are different ways that you want to manipulate the data table for your analysis purposes. Let's go back. Then just down here, we calculated the probability frequency. Now we're going to go to, for the time being, one of my prouder achievements in R, accomplishing loops. This is going to run for a while, so I'll put that in the background. And one of the cool things that my office does is part of my performance plan is professional development goals. And because I'm still very unfamiliar with coding, like I know a little bit SAS, I'm working with R, I'm trying to teach myself Python. But part of my professional development goals for last year was I wanted to learn how to run loops. Basically, lucky for you, I did not bring any of my really old scripts where I basically had to go through data tables, and it was a lot of unnecessary code running the same code for different parameters. And the thing I like about loops is you can go through you create a list and it loops through that and does the calculations for you. Let me see, it's done running? Okay, no. I think that takes a little while to run. Share my screen. So I'll talk about the loop that is running right now. So basically, I wanted a cumulative probability. If we're trying to figure out, what's the probability that a trip going between this zone and this one zone and another zone was going to use a point of entry, what was the probability that was going to happen? And so, bear with me, it's a bit complex. Even explaining it to my boss sometimes is very confusing. So I created an empty variable in this entry frequency data table. And I set it as a numeric variable, but left it blank. And then I created a list called, I'm not sure why I call it rand. But that's a list, and it's a list consisting of the numbers 1 through the number of rows in entry frequency. Basically what this does is once we get further down, it'll loop through every row number in the entry frequency data table, and just make sure that we go through every one. So this is also, I'll come back and explain that later because you might see that spread throughout. So the cool thing about loops, like I said, is there are lots of conditional ways you can go through large data sets without having to write out the code every time. So this is a for loop, basically saying for a value X in this list, you will run the following pieces of code. And so it'll go, so for 1 and it'll go through there. So I set these variables Y and Z, which because there are 3 different matrices that are being used to calculate the probability, I want to check to make sure that the observation before and after were of the same origin, destination, point of entry group, if that makes sense. So this goes through in the if loop. So if the value of Y is greater than 0, then it calculates entry frequency at this observation number, which say, for instance, we're at number 1. So for 1 in list 1, Y equals 1 minus 0, 1 equals 0, and Y equals 0, and Z equals 2. So if Y is greater than 0, which is not, it would skip down to this. Now say X equals 2. So Y equals 1, Z equals 3. Because Y equals 1 is greater than 0, and thus if entry frequency at observation 2, if the origin zone at entry frequency 2 equals the origin zone at entry frequency observation 1, and if the destination zone at entry frequency 2 and the destination zone at entry frequency Y are the same, you'll run this loop, which is another embedded loop, which is if entry frequency 0, if the origin zone at entry frequency 2 or X is equal to the origin zone of entry frequency observation 1 or Z, and the same holds true for the destination zone, then the probability at entry frequency X is equal to the probability of entry frequency X probability plus entry frequency Y probability. It's really confusing again, obviously, but I guess I'll try and break this down a bit. So this syntax here, this lets you, within a data table, if you put something, this X or this number in a comma, that means the row observation. So this goes through row by row for sorry, I'm pointing at the screen and you cannot see that. My apologies. This just lets you know which row number to look at. And so what this is going to do is basically go through every row of this entry frequency data table and calculate what the probability value is. And now you might be confused as to why there's prob and probability. I created the probability fraction, which was just, it was more of a share. So like of the 3 observations, what was the share that point of entry observation was, whatever. And so you just add, and then probability ended up being the cumulative probability for each origin, destination, point of entry zone. I apologize if this gets really confusing. This is like beyond in the weeds of transportation policy, but I hope it's interesting. I'm going to keep going. I think, all right, good. So this ran all the way through. It took 427 seconds. So yeah, I guess I can go back and explain that. So the proc time. I only recently discovered how to use this, which I appreciate because I tend to run some pretty complex loops. Also understand that this is one of the simpler loops that I've had to create for my tests. But yes, so proc time. This is basically, it takes a timestamp of the processor processing time. I set it to this value, PTM0. And then once I finish either a loop or at the end, there'll be a final piece of code. Once I finish that, then it'll take the current processing time information minus the past processing time information, and it gives us the result. So I can figure out how long this is taking. All right. Do some more quality assurance, checking probability. So we're going to run this loop. Yeah, I'm going to run the loop. I'll explain it a bit more later. And this one takes a while, so I'm just going to let that run and just talk. So yeah, this is one of the more, well, not the simplest scripts. It feels simple to me now, but I remember writing it. I remember writing it and feeling really stressed. I don't know everyone's background with coding, and I think sometimes you can see people who can just like sit down at a coffee shop and like whip out some crazy piece of code, and you're having a hard time figuring out how to subset. And I've definitely, it's good having, so it's also hard. My younger brother studies computer science, so he knows like C and Python and Ruby and all this jazz. He builds his own computers. So when I talking about coding can be a little I sometimes feel like I have an imposter syndrome. But like I've realized that it's a lot more it's fun problem solving. It's like learning French, so I studied French and Arabic in college. So it's like learning those languages. It's just learning the sort of grammatical structures, the sort of psychology behind it. And it seems intimidating and foreign at first. And then you just keep Google translating, or in the case of code, Googling, how do I do this? And then bookmarking it. And Stack Overflow. Stack Overflow is the best. I stand by it. If you have a question, just Stack Overflow it. But yeah, it'll feel weird. You'll like slowly progress, and you'll be teaching a master class and be like, I don't know R, except wait, I guess I do. I've been doing this through 3 years. Yeah, I don't know. This is more my like ad hominem approach to coding. It's interesting, and you don't have to. I think the other thing is you don't have to be like, I went to a big data conference a couple weeks ago, and it's interesting because I think in my mind, big data and data scientists are these high-end nerds working for like some big Fortune 500 company processing like financial data. And it's like, well, that's not what I do. I work for the government and process simulated transportation models. But it's what I do. And I guess I am slowly becoming a data scientist. And I think, especially for anyone who's beginning and it seems intimidating, and you may feel like you don't belong, you do. And if you don't belong, then you make yourself belong. Yeah. So, all right, this is going to run for a while. I'm going to go back and explain a bit more of what the loop is doing. So yeah, this was the final loop. I'm trying to remember again what this is doing. So originally what I was calculating, I can't run that. That takes like 8 hours to run. But originally what I had this calculate was this huge bunch of code. And actually further up, where did I have that? Oh, yes. If you have any kids who want to know why on earth they'll need math or geometry, tell them they may need to remember the Pythagorean theorem so that they can calculate the distance between a origin node, a destination node, and a point of entry node. And they'll be happy that they remember Mr. Huizinga drilling it in their head to remember the Pythagorean theorem, because you never know when you'll need it for a code. But yes, so this was significantly more complicated. The POE matrix, this code here was simply saying what was the origin, the destination, did it enter into the region or did it pass through? And within the greater metropolitan region, did it pass, was origin or destination within the 7 northeastern counties of Illinois? This bigger code was actually going through and calculating specifically creating a file that showed origin, destination, point of entry, code, point of entry node. It calculated the distance, used the distance between each origin and destination node and each point of entry and point of exit node, using that to determine which of the 2 nodes was the entry node and the exit node. Yeah, it was fun writing. I was very happy when it finally ran. It just took a long time. It was very hard to explain to my boss, very hard to explain even clearly now. Just know, basically, it was trying to figure out what simulated trucks and trains. Well, actually, no, these are just trucks. I still have to figure out trains, how they go through the Chicago metropolitan region. But yeah, let's see if this is still running. I feel bad. I can't remember. I normally run this on a modeling server at work, which has significantly more processing power than my desktop at home. And so the processing time may be a bit different. But yeah, I mean, it's weird talking to a camera and not seeing yourself. But yeah, so I guess I've been explaining the sort of short-term goal of this code. I guess I can talk a bit more about the long-term goal, especially because although my job requires me to code, I feel like I'm much more of I would describe myself more as a city planner, that's usually what I say because I work for a planning agency. So what these what this ultimately will do is we'll apply it back to our regional freight model, and hopefully that'll give the goal of this model is to give us an understanding of what freight is coming in and out of the Chicago region. Despite spending my time looking at code, despite doing traffic forecasts, my focus is on the long-term planning for the Chicago metropolitan region. And so I'm gonna veer away from tech and talk a little bit more about planning and urban policy. So Chicago is basically the heart of freight in this country. Stuff comes in from the coast, but it has to pass through Chicago. But unfortunately, which is the case in most of the country, there's not been enough investment in the sort of infrastructure to basically, which leads to delays. We spend billions of dollars dealing with delays of getting trucks and trains and airplanes and cargo in and out and through the Chicago region. And that's not good. It's not good for air quality of the people who live in those areas. It's not good for the national economy if we are spending money waiting for goods and stuff. And so we're trying to develop this model so we can better predict what's coming into the region, how it's coming into the region, how it's going through, and try to prioritize how we invest our money. The fortunate thing as a planning agency is we're halfway between state and federal government. And so we can take federal transportation dollars and appropriate it around the Chicago region. And so we're using these models to try and validate and have some data behind how we prioritize investments. So that tends to be the more bird's eye view, and going back down, you get to writing code in R and learning R so that you can create a better region for the people that live here. Yeah, and I think that's been the cool thing for me. I am seeing how to connect the more, there's emphasis on the hard sciences, on STEM, on coding and whatnot, and I felt very disconnected from the sort of social motivations I have. And this job has allowed me to see the value of both and also how to reconcile them for bigger things. And it's been very cool. It's also, strangely enough, mentioning my brother has helped me kind of understand him a bit more. I trying to think how to best describe it. So I was giving this analogy to a friend last night. I don't know if any of you guys are Star Wars fans. Actually, how much time do I have? All right. Hopefully this will be done soon. I was giving this analogy, Star Wars fans. My brother and my dad got us into Star Wars, but my brother was a lot more interested in the ships and in the droids, and I was much more interested in the Force and the lightsabers and the feelings. So we both enjoyed it. We just approached it from different angles, and I think that's what I've learned, is that you can kind of create your own sort of Star Wars where it accommodates the Force and lightsabers, but also droids and robots. All right, this is still running. Yeah, see, this is why I should just buy like a $1,000 processor to run models on my computer. I'm gonna add this code in real quick so it'll finish up when it does finish.
And no worries, Lafayette. We can also jump into Q&A until.
Yeah, we can totally do that.
Finish your Star Wars story because I'm at the edge of my seat here.
I mean, that was just it. We just approached Star Wars from different angles, and as kids, we loved the droids and the robots. And I was like, "You're a nerd." And lightsabers. But now that we're older, we can appreciate the fact that there's something cool about the ships, and there's something cool about the droids, and there's also something cool about the Force and about lightsabers. And in the end, we're both fans of Star Wars, and that's all that matters. But yeah, while that runs, I'm happy doing Q&A.
I love that. No, that's awesome. Yeah. Let's jump into a little bit of Q&A, and I think it actually started to talk about several of these things or several of these questions and where they're already throughout the presentation. But so I'd love to hear a little bit more about, I love some of the quotes that you had. You mentioned that you felt like numbers were emotionless, and you've sort of taken these things that maybe initially seemed a little cold or kind of not really your bag, and you've worked them into the things that you're passionate about. So can you talk a little bit about how, what advice you have for students who want to do something like that, where they want to take learning to code, bring it into the realm that they're passionate about to solve a problem? I mean, what you're doing is, really civic minded. We've got a lot of students that ask about that all the time. How do they get involved in their community? How do they get involved in the city? How do they, get involved in the nonprofit community? So any advice for people that are just starting out on their journey?
Yeah. I mean, I think the thing for me is, I was fortunate enough in that my job required. Like I love my job, and it gave me an opportunity to learn to code and to pursue some within the realm that I enjoyed. And now, especially if you're just getting started, it is what's the best advice? I would say finding a project that you want. So like I started teaching myself Python. We have people use Python at work, but I don't necessarily do that. But I wanted to use it to look at like housing data within the city of Chicago to try and figure out a question. And I think that's the thing. There's certain things about life that don't have actual tangible answers, and that's where like numbers fall apart. But there's certain things that are better informed by using data and numbers. There are certain trends that give you better insights, and so for me, it's looking at numbers and coding and these hard sciences as providing more insights into non-tangible things, or more nebulous things. Our goal is to make Chicago a better place, like a more equitable place, a better place to live. That's a very big question. And what constitutes a good place to live is very subjective by different people, but we can look at some very objective things. We can look at big objective things and try and fix those, and then use those to inform our discussion. So whether it's like learning how to look at like employment data, or trying to get out of the realm of like social services, because that's my day to day. It's just trying to figure out what sort of tangible thing can help give you insight into the non-tangible questions that you have. It's not non-tangible. The more nebulous questions that you have, the more subjective questions. I don't know if that.
No, that's fabulous. I love that. I know that, Kara and I talk about that all the time. So she'd be really happy to hear that you said that, where the basis should really be a project, or it should really be something that you're trying to answer. I think that's so important when people are first starting out too, because if you don't have this larger goal that's bigger than the thing you're trying to learn, then when you get stuck or have like a difficulty with a particular concept, which is inevitable no matter what you're learning. And I love all the parallels to language, learning French and Arabic and other languages that you drew. It's because it's the same thing. You're gonna get stuck. But I think it's important to remember that when you have that larger goal, it's easier to get past those moments where you're stuck, and that this big thing, it's like bigger than you in that one moment where you're stuck or having difficulty. So I think that's fabulous advice. And it's one of those things too that I think, as someone who has been coding for a while, if I'm like starting to learn something new, because I also recently started to learn Python, which is awesome. And you kind of forget that, because you think, oh, I know that I'm going to get stuck, and I got this. Like I'm not gonna get like too depressed if I get stuck because I've been here before. But you do forget. And I forgot when I first started to pick up Python, I was like, oh my god, I didn't even think about the thing that I wanted to do this for, and bring that into my project and bring that into my learning, because it slows you down if you don't. And that's the other thing.
Well, that's the thing. It's like trying to just like putz around learning for no purpose. It just makes it hard, unless you're the sort of person which I'm not. If you're the sort of person who's like, I just want to learn this to learn it, and like focused and driven and like make up examples to test it out. If you're that sort of person, great, go ahead. If you're not, finding something that you want to learn. So, but yeah.
Yeah, I totally agree. Awesome. So another question that we got from students is, what are some of your favorite resources right now for learning R and maybe Python? What are some things that you would point people towards, whether that's blogs or courses or books?
Yeah. So I'd have to send you, I had basically someone had given me a PDF, and there was a website that I used like a couple years ago. I can't remember the URL. Might have it on my phone. But yeah.
If not, I can get it from you later and just add it at the bottom of this video for students.
Yeah, I would say that. Yeah, like I'd kind of mentioned it before. So basically, my boss gave me some sample script when I first started, just to play around with, to understand. And then it was a lot of looking at the. So if you look, I can't remember the website. If you just look up R, that has like a manual, which is kind of, it's hard to look at a manual to learn R, but it is helpful. Like if you want to know what things it can do. Otherwise, yeah, it was a lot of at this point, it's been a lot of playing around. Google's my best friend. Stack Overflow, that's where it's at. Yeah, I guess that's the thing. I'll send you the link to the sort of like online program that I did. Otherwise, yeah, it's just been a lot of toying around at work. So
I love that. No, that's awesome. And I'll go ahead and post that link at the bottom for students. Well, cool. I know that we want to check back in on your script and see how that's running, because we're getting pretty close to time here. So you want to let us know how it's doing?
Okay, it is done. Share my screen. All right, it is done. So what this ended up doing was calculating the probability of a trip entering a trip between two different zones and whether it entered or exited the metropolitan region. Actually, let me. Okay, so this is the final output. And like the data table name says, POE is simple. So it's the origin zone, the destination zone. Was it given a point of entry code? And like I said, point of entry just meant you were coming from outside of the region and entering into the region. So these were all internal origin destination zones, so it did not have a POE code. And then this NCMAP thing, that was something I added because, so our modeling region includes so the Chicago metropolitan region is just the 7 northeastern counties of Illinois, but our modeling region includes parts of like Indiana, some more counties in Illinois, parts of Wisconsin. And so we could figure out what was coming into that greater region, but we wanted to know specifically what was coming into the CMAP region. So I just made a little flag, and so it says, okay, this was within the region. And because it's within the region, the probability of it being within the region, so the probability of it not having a point of entry code and being within the region was 1, which is 100%. And the probability, and so because it neither entered or exited the region, and had no in POE or out POE. And let's see if I can find. Simple. Okay, so it's a little more complex. So this is the zone for, I believe, Mexico and I don't remember which state that is. And so you can see here the probability of a trip going from Mexico to this state and not passing through the region was about a 33% chance. So because it passed completely through, it was neither in CMAP and it had no entry or exit. But there was, because it jumped down to a probability of 1, that meant that it was the remaining 66%. There's the remaining 66% probability that it was going to pass through the POE codes 18, and so it would have an in POE and an out POE. And so we use that to start calculating, just to be able to flag and determine what trips are going in and out of the Chicago region. But yeah, so that is the code, and it took 2,374 seconds, which I'm still terrible at mental math, so I cannot tell you how many minutes that was. But yeah, so that was a little intro.
I love it. Thank you so much.
Oh, you're welcome.
Yeah, and so just for the students, a little bit of housekeeping before we wrap up for today. So we're going to have this video available for you guys if you want to go back and rewatch it. And there's a lot of code to look at, so definitely feel free to go back, hit pause, and full screen some things so that you can check out what Lafayette was working on there. And thanks you guys for being here in Lafayette. Where, I know you said you're not super active on Twitter, but where can students find you? Do you have an online presence that you want to share with us?
I mean, the closest thing I have is like Instagram. Yeah. I am like not a model millennial.
That's all right. You guys can always follow Skill Crush and definitely come back and rewatch this masterclass. Lafayette, I want to thank you again so much for being here. This was fantastic. I will get the link for that R manual, I believe, that you mentioned, and get that posted for students later on, so you guys can check back in a couple of days, and I'll have that updated for you. Thank you so much for being here. You're fabulous.
Thank you for having me.
Have a great weekend, everybody.
Right. Bye.